This second video on factoring will pick up where we left off by going over the techniques that can be used for 3- and 4-term polynomials. Now we're going to look at the easy trinomial factoring. The easy case happens whenever you do not have a number in front of the x squared. So the way this works is you find the pair of numbers whose product is in this C spot, the number by itself, and the sum of those two numbers is B. And the two numbers you pick, the ones whose product and sum make this B and C value, I'm going to use the numbers m and n, or the variables m and n, to represent this for a second. You just write the factored form as x plus m and x plus n. Again, the order in this case doesn't particularly matter. Just be careful with the plus or minus signs to make sure things multiply and add correctly to the given numbers. Please do not confuse this with what happens when there's a coefficient in front of x squared. That's the next technique we'll look at. And don't forget that you can check your answer by just foiling this back out to make sure your answers work the way you expected. Since neither of these examples have a number in front of x squared, I already set up my two binomials as being x and x for both of them because those parts aren't going to change for this. That's what's nice about the easier factoring trinomials. So now you just need to think about numbers that multiply to 12 but add up to -8. So in this case, I'm going to pick -6 and -2. Now there were other numbers that multiplied to 12, but this is the only possible pair that also added up to -8. So -6 times -2 is 12, -6 plus -2 is -8. That's why this is the correct factoring. And then again, foil this out to check your answer if you need to. Here again, I need to pick two numbers that multiply to the last number. So a negative, that means I'm going to have 1 plus and 1 minus this time. And then I need those numbers to add up to a +2. So I'm going to pick 5, +5, and -3. Because if you multiply those numbers together, you get -15. But if you add those numbers together, you get a +2. Now for the harder case, when we do have a number in front of the x squared, basically you want to list out all of the factors of this first number and the factors of this last number separately. And the factors of the ax squared piece are going to be the first numbers in each binomial. And the factors of this last number will go in the last spot of each binomial, the second spot in each set of parentheses. And then basically you just want to keep guessing and checking from the pairs that you're picking until you get one that foils together and correctly gives you the original expression. It's very important to check your answer on these because this is the easiest one to make a mistake on. Think that your numbers will multiply or add correctly, but find out that it doesn't actually work on. So this is what I meant for step 1. Take whatever this first term is and find all the different possible factors of it. So it could be 4x times x, or it could be 2x times 2x. These are the possible terms that I'll be writing for the first part of each binomial. And then the factors of this last term, this 3, there's only one pair of factors for this. It's got to be 1 times 3. So then you just pick one of the factors for the first term and you write them in. And then you pick one of your pair of factors for this second piece, the last term, the c value, and you write them in somewhere. And then make sure you think about whether they're going to be pluses or minuses. And then you have to check your answer, because if that possible combination didn't work, then you might want to flip. You might want to put the 1 here and the 3 here instead. Or maybe instead of doing 4x and x, maybe you want to pick the 2x and 2x for your first terms. So you write out all the factors, make a guess with it, and then check your answer. 4x times x is 4x squared. And then 4x times 1 is 4x. 3 times x is 3x. And 1 times 3 is 3. So if you combine the like terms here, we end up with 4x squared plus 7x plus 3. So that's how I knew that this was the correct factoring. This is just me checking my answer, but that's how I know I put the right numbers in the right spots for my breakdown here on number 9. So again, I've written my factors of the first term. The only way to get 3x squared is to do 3x times x. And the only way to get 6 is by doing 1 times 6 or 3 times 2. So I don't have many choices for the first part of each binomial. I can just go ahead and write in the 3x times x. For the second number in the binomials, I do have choices. I could either pick 1 and 6, or I could pick 3 and 2. So in this case, I'm going to pick the 3 and 2 combo. And the more you practice this, the better you'll get at making the guess correctly the first time. I know that I need the numbers to add up to a negative, So I want a bigger number for the negative product and a smaller number for the positive product. So by putting my plus and minus signs this way, I end up with minus 9x plus 2x if I FOIL it out. And my last product gives me the negative 6, and my first product gives me the 3x squared. So that's how I know that this is the correct choice. Remember, if you picked the wrong numbers, like 1 and 6, or if you put 2 and 3 in the wrong spots, then when you FOIL this out, it will not match your original expression. That's okay. Just do it again and try different numbers or rearranging the numbers until you get one that checks correctly. The last technique we're going to look at is called grouping. This one only works when you have 4 terms in the expression. So basically this is just doing the GCF multiple times. You take your 4 terms and you look at just the first 2 and find the GCF, and you look at just the last 2 and you find the GCF, and then you take those matching binomials, because it should be the same thing, what you have in parentheses, and you pull that out. You take it like another GCF. So I have 4 terms here. There is no GCF for all of them. If I look at the first 2, these have x squared in common. So I write that out. And then that leaves me with x plus 2 in parentheses. And then I look at the second 2 terms. These have negative 3 in common. So I'm going to divide both of those by negative 3. And then that leaves me with x plus 2. What you have in parentheses should match. If it doesn't, then this either doesn't work or you did it incorrectly. Since the stuff in parentheses matches, you write that stuff outside, and then you have another set of parentheses. You're basically taking the GCF out of both of these. So if I take out the x plus 2, I'm left with x squared. And then from the other term, I'm left with the minus 3. So your final answer is what you have inside parentheses and what you have outside the parentheses. And then this may be factorable more. You may be able to do like a difference of squares or something after that step. Second example, find what these numbers have in common here. So from looking at the first 2 terms, I'm going to take out 4v squared, and then 28 divided by 4 is 7, and v cubed divided by v squared is v. 16 divided by 4 is 4, and v squared divided by v squared cancels. And then do the same thing with this part. So these numbers are both divisible by negative 3, which will leave me with 7v plus 4. Remember, the stuff inside parentheses has to match, so if you get the wrong sign, just double check your work. Negative 12 divided by negative 3 was positive 4. So since my parentheses match, I write what's inside the parentheses and what's outside the parentheses separately. So now I have 4v squared minus 3. And remember, if you're not comfortable or not confident that your answer is correct, just FOIL it back out and make sure it matches your original question. So while we have gone over all of the individual factoring techniques, I've referred a few times over the last 2 lessons on how sometimes you might factor something and then be able to factor it again. So I just want to talk a little bit about what that will look like and give you some tips on when you can and when you can't do it. Basically, anytime you factor an expression, just look to see if what you've pulled out front or whatever you have in parentheses, see if another factoring technique can be applied there. The biggest, most important recommendation I can give you is always look for a GCF first, no matter how many terms are in the polynomial, because that will dramatically reduce the complexity of what you're working with. So for our first example here, number 13, we have what matches the difference of squares technique, because I know that x squared would be x to the 4th, and I know that 4 squared would be 16. So I can break this down as x squared plus 4 times x squared minus 4 using the difference of squares technique. Now let's look at the factors I just created. This one cannot be factored anymore. We learned a difference of squares, not a sum of squares. So since this is a plus, it can't be broken down anymore. However, on this other factor, I do have another difference of squares. So sometimes it might even be the same technique getting applied multiple times. So the first factor I'm going to leave alone. We cannot do anything else to the x squared plus 4. But this part will get broken down as x plus 2 and x minus 2. Please be careful about only using this technique when you have a minus sign in there. The third power version, the sum and difference of cubes, that one does work for either a plus or a minus. But when you're dealing with things to the second power, it only works for a minus. So now this has been factored completely. For the next example, number 14, before I do anything else here, I want to take out the GCF because I see that every single term, all three of these terms, are divisible by 3 and they all have at least an x in them. So I'm going to take the 3x out. So if I divide the first term by 3x, that will leave me with x squared, and then it's a plus. If I divide 21x squared by 3x, 21 over 3 is 7, and x squared over x is x. And then it's a plus again, still a positive divided by a positive. 30 divided by 3 is 10. And x divided by x cancels. Remember, you can check this quickly by just saying what would happen if you multiplied the 3x back through all three terms. So you would end up with your 3x cubed, 21x squared, and 30x. That's how I know I did this correctly. Now this is done. There's nothing else that can be factored here, but this piece, this might still be factorable because we have learned some techniques for dealing with trinomials. This is the easy trinomial case because I don't have a number in front of the x squared. So what I'm going to do here is look for two numbers that multiply together to equal 10, but add up to 7. And so the numbers that work in this case are positive 5 and positive 2. So just remember, if you factor something, it might still be possible to factor it again. Look out for that occurring. Also, one last helpful reminder, when you're dealing with the sum or difference of cubes technique, remember that one has a trinomial that looks like it can be factored, but in fact it cannot. It is impossible to break down the trinomial from the sum or difference of cubes technique. So that's all for our review on factoring techniques. Thank you.